So the next is HTM or homogeneous transformation matrix. So what is of the HTM or homogeneous transformation matrix? So the HTM is a 4x4 matrix that combine rotation and translation transformation. It's enable us to express both the position, translation, and orientation. Rotation of a coordinate frame relative to the another coordinate frame. The image below are the computation of homogeneous transformation matrix of articulated manipulator. So in this video, show the kinematic diagram. I'm going to draw the direction in here. If your direction were different, then when you tested your switches, fill in your kinematic diagram. So from the base, this is the theta 1, positive theta 1 because of the counterclockwise. So from the second joint, there will be the theta 2 because the link length move up. From the third joint, there will be the negative theta 3 because the counterclockwise. So from the base n minus 1, the say sub 0 is pointing to the up and x sub 0 is pointing to the right and y sub 0 is pointing to the side. So from the second joint, say sub 1 is pointing to the front and x sub 1 is pointing to the right and y sub 1 is pointing to the up. And from the third joint, the say sub 2 is pointing to the side and x sub 2 is pointing to the right and y sub 2 is pointing to the down. From I get the joint by the copying frame before it. After the copying the links of from the third joint to the fourth joint, I also need label my link lengths. Now I have everything I need to find the homogeneous transformation matrix from frame 0 to frame 3. So good day. What is homogeneous transformation matrix? So this is the equation of homogeneous transformation matrix. So in this video, I will demonstrate how to solve the equation of homogeneous transformation matrix of 4x4. So HTM is describe the rotation and position of mechanical manipulator. That's why homogeneous transformation matrix is combination of rotation matrix and position vector. So denoted as a H, and it also has a script of reference frame and script of for the projected frame. The matrix shown in the formula obtaining the homogeneous transformation matrix, it has a 4x4 matrix, composed or 3x3 matrix, combined with 3-1 position vector. So, our Denabit-Herbert DH table provide of necessary parameters to calculate the HTM or H frame in the H transformation. So, for our H01, for our first H01, For our H01 first column, based on the DH parameter, this is the first column. So, cosine theta, this represent the cosine of the first joint angle. So, this is the first cosine theta 1. So, next is the cosine theta is represent the based on the DH parameter. So, the next column is 0 because there's no rotation. So, the next column, sin theta is this represent the sense of the first joint angle theta. This is the distance along the x-axis of the base frame represent the link length. So, this is the sin theta 1. So, pang fourth column is 0. So, the second column, second column, so, this is the H01 homogeneous transformation matrix. So, let's proceed the second column. So, sin theta 1, this represent the sine of the first joint. So, this is the sin theta because of this consists of first joint. Sin theta 2. This is the sin 1 and this sin theta 2. So, the second, there's no rotation. The answer is 0. There's no rotation. So, the third one is negative cosine theta because the rotation is counterclockwise. Cosine theta 2. So, the next is 0 because there's no rotation. So, the third column, there will be 0 because there's no rotation between the manipulator. So, this is the 1 and 0 and A1, the first link length. So, for the fourth column, 0, there's no rotation. 0 again, there's no rotation. 0 and 1. So, let's proceed the H12. So, let's proceed the H12. So, transformation from the frame 1 to frame 2 based on the DH parameter, 0 theta 2 is equal to 0 plus 0 theta 2. So, cosine theta, represent the cosine of the second joint angle. So, this is the cosine theta 2. To represent the second angle. So, the next is Sin theta is to represent the since of the second joint angle. So this is the negative because of the counterclockwise. So negative. Negative sin theta 2. And the next is 0 because what? Because 0 is not no rotation. And the next is cosine theta. So the second column is sin theta is represent the second angle. So this sin theta 2. And the first is cosine. There will be the cosine theta 2. And 0, there's no rotation. And A sin theta. So the next third column is 0, there's no rotation. 0, 1, 0. The fourth column is 0 again. 0, 0, 1. And let's proceed the homogeneous transformation matrix 2, 3. Homogeneous transformation matrix H23. Based on the DH parameter, 0 theta is equal to 0 plus theta 2 equal to 0 degree or R1 equal to AD2. So cosine theta 2 is represent cosine of the angle. So this is the cosine theta 2. So the first is negative. For the second angle of H12, there will be negative sin theta 2. Negative sin theta 2. And there will be 0. And A is equal, A is cosine theta. So let's proceed the second column. Sin theta is to represent the second angle. There will be sin theta 2. And there will be cosine theta 2. So there is 0. There will be no rotation. And A1 is cosine theta 2. No. This is the sin theta. So third, there will be 0. There's no rotation. 0, 1, 0. So 0, 0, 0, 1. So let's proceed the fourth. H 3, 4. So this is the H01, H12, H23, and this is the last H24. So the next column is cosine theta 1, cosine theta 2, cosine theta 3, minus negative cosine theta 1, sin theta 2, sin theta 3. Next is sin theta, negative cosine 1, cosine 2, sin theta 3, negative cosine 1, cosine 2, sin theta 2. The third is sin theta 1. Next is A2 cos sin theta 1, cosine theta 2, plus A3 cosine theta 1 cosine theta 2 cosine theta 3 negative A3 cosine theta 1 sin theta 2 sin theta 3. Second column is cosine theta 2 cosine theta 3 sin theta 1 negative sin theta 1 sin theta 2 sin theta 3. Next is negative cosine 2 sin theta 1 sin theta 3 negative cosine theta 3 sin theta 1 sin theta 2. The third is negative cosine 1. Next, A2 cosine theta 2 sin theta 1 plus A3 cosine theta 2 cosine theta 3 cosine 1 negative A3 sin theta 1 sin theta 2 sin theta 3. The third column is cosine theta 2 sin theta 3 plus cosine theta 3 sin theta 2. The third column is cosine theta 2 cosine theta 3 negative sin theta 2 sin theta 3. The third is 0 because there's no rotation. And the fourth is A1 plus A2 sin theta 2 plus A3 cosine 2 sin theta 3 plus A3 cosine theta 3 sin theta 2. The third column is 0, 0, 0, and 1.